Now that we've talked about both the linear and quadratic approximations for functions, I want to expand the idea to higher degree polynomials. And these are known as Taylor polynomials. For this, p sub n of x, so the nth degree polynomial, is going to be f of a plus f prime of ax minus a, so the linear approximation. We then have plus the second derivative over 2 factorial times x minus a squared. So that's our quadratic term. Before I just had a denominator of 2, but that's the same thing as 2 factorial. And then we keep going up to the nth derivative of f at a over n factorial times x minus a to the n. The more compact version of this is the sum from k equal to 0 to n of the kth derivative of f at a over k factorial times x minus a to the k. So I want to try to find some of these polynomials for f of x equal to cosine of x at x equal to 0. In fact, I want to find p1 through p8, which seems excessive, but it's actually going to work out kind of nicely. So in order to do this, I'm going to need to start taking derivatives. I know f of x is equal to cosine of x, and we know the derivative of cosine is negative sine. The derivative of negative sine is the negative cosine. The derivative of negative cosine would be positive sine. And then the derivative of sine would be cosine. In order to find p1 up to p8, I need the first 8 derivatives. However, these are going to cycle through. So the fourth derivative, the fifth derivative would be back to the first. And so we have this cycling thing with cosine and sine. We then need to evaluate each of these at my center at x equal to 0. We know that cosine of 0 is 1 and sine of 0 is 0. That tells me that my second derivative is negative 1, third derivative is 0, and my fourth derivative is back to 1. So now let's start looking at our polynomials. P1 of x says f of 0, which is 1, plus f prime of 0, which is 0, times x minus a, which is 0. So I get that P1 of x is just 1. P2 of x is then going to be P1 of x plus the quadratic term, which is the second derivative, negative 1, over 2 factorial times x squared. P3 of x would then take this and add the cubic term, but since the third derivative is 0, it's actually the same as the second polynomial. So now let's look at P4 of x. I start with my third polynomial, and then I add my fourth term, which is the fourth derivative over 4 factorial times x to the fourth. Once again, my fifth derivative is 0, so it's going to be the same as P4 of x. And we can continue this process to get P6, P7, and P8. The next thing I want to do is use this idea of Taylor polynomials. In particular, I want degree 0, 1, 2, and 3, and I want to use them to approximate the square root of 10. And I'm going to do this by letting f of x be equal to the square root of x. I now need to choose my center. So far I've been using my center as 0, but I'm actually not going to do that here. Since I want to approximate 10, I want to use a center that's very near to 10, but that I can easily evaluate f of. So I'm going to let my center be equal to 9. This is because 9 is really close to 10, and I know the square root of 9. So now we need to start by finding our derivatives and evaluating them at our center. We start with just our function, which I'm going to go ahead and write as f of x to the 1/2, and then we evaluate that at 9. We have the f of 9 is equal to 3. Now we start taking derivatives. The derivative of x to the 1/2, we bring the exponent down and subtract 1. So I have 1/2 x to the minus 1/2, which gives me 1 over 6 when I stick in 9. We now need the second derivative. which is negative 1 over 4 times x to the minus 3 over 2. Evaluating that at 9 gives me negative 108. And finally, the third derivative is 3/8 times x to the negative 5 over 2, which is 1 over 648. And that's as far as we need to go with our derivatives since I want to consider n equal to 0, 1, 2, or 3. So now let's start evaluating, and we really need to use the Taylor polynomial idea. So I have that P3 of x is equal to 3 plus 1 over 6 times x minus my center, x minus 9. I then need my second derivative, negative 108 divided by 2. So I went ahead and wrote that as 1/2 times 108. And then x minus the center squared, so x minus 9 squared. The third term is my third derivative, 1 over 648, divided by 3 factorial, so times 1 over 6, times x minus 9 cubed. In order to find the square root of 10, I stick 10 into this polynomial. And if I work that out, I get approximately 3.162. So that's our approximation for the square root of 10.